Hello, and welcome to Advent of Code the day after. Today we'll be doing day 8. I'll start it here right when this says 1650. That'll be starting at 7:10 a.m. You can see yesterday I started at 13:10, so it took me about 17 minutes. The day before I started at 11:20, me about 20 minutes. I did not record exactly when I started on other days, um, but I've concluded I can't really do midnight anymore. So this is what I'm doing now instead. Um, and here we go. Oh man, these electrical junction boxes again. Not getting too junction connect all the junction boxes in 3D space. This describes save on nights. I think as close together as possible according to straight line distance. Ah, okay. By connecting these two junction boxes together, connecting them as a single circuit which contains the two junction boxes. Those two junction boxes. Please allow all the circuits. Making the 10 shortest connections, there are 11 circuits, one which contains 5, 4, and 40. Connect together the 1,000 pairs which are closest together. What do you get if you multiply together the sizes of the only the three largest circuits? Okay, sure. Um, Donaldson is two, okay, that's just so that I can run this with the sample data as well. Um, and also let me go grab that sample data. C8. Okay. Now, and let me also say lines and data equals uh, list of int v for v in l dot split that of comma for l lines. Good lines. Okay, so we need to find the closest. And I know I don't need to pass it in because it's all there, but okay. So yes, let us find all this, and then we will. Okay. Entry. Okay, so what do we got to do? Well, I guess we've got to make all of the connections. Uh, so right. So what I want is I want all of the pairs, and I want to sort the pairs by okay. Uh, Pairs equals data tools dot combinations of uh, range and data and two at a time. Okay. And then I'm going to do, actually, I want a list of those. So now I'm going to do maybe it's pairs dot sort p equals lambda p comma q list square between a0 minus b0 squared plus a1 minus b1 squared plus a2 minus b2 squared. Okay, is square data bracket p and data bracket q. You know what? I'm not gonna worry about that. All the ideas queries is that. Then going to take the 1,000 smallest lines, so the first 1,000, and so then connected. You know, and connect. Okay. Now I have to find the three largest bits. Actually, here, let's do set. And for X in connected, actually, connected, add X bracket 1, X bracket 0. So we've added in both directions. Then keep going is true. Okay, so what I'm planning to do now is I'm planning to um, go through and merge all of these things into a group. So X colon X or X in range data, lang data. I'll keep going. Okay, keep going. It's false. For okay, so what I want to do is I want to take actually x2 bracket x um, for okay, so now what I want to do actually here, I want to change this. I want to change this. I want to change this to a map. I want to change this to a dictionary of um, yes. So I want to change this to a dictionary from thing to x colon bracket y for x comma y in connect. And then here I want to say x1 equals connected dot set. Yeah, okay. I forgot to do it this other way. Okay. Um, there. So now everything is connected to everything else. So for um, okay, but now group noms. Shoot, I kind of want both of them. Damn it. Groups. nums. Actually, here. X, X. Let's see if I can do this. Changed. Let's not do changed equals list range lang data. Okay. Well, changed for y in changed um and is connected dot get of y that for x in neighbors um if if group nums of x is greater than group nums of y, group nums of x equals y, and n changed dot add x changed equals sorted and changed. Okay, so we go through, do that, we do that, we do that, we do that, we do that. Okay, then what do we have? Then I need to find, okay, so that should get me until I've got everything that is connected. Then groups, that, and for x in group nums do groups dot set default group nums x dot end x. Then uh, sizes equals len g or g in groups dot values. Then we do sizes dot sort. Reverse equals true. And then we return sizes bracket 0 times sizes bracket 1 times sizes bracket 2. Okay. Okay, so we're not gonna check that right now. Oh, lambda character is gonna be parenthesized. Okay. E dist 0 E bracket there. That's what it's complaining about. 636. Copy. Let's just try that. Probably won't be right. Right. Oh, wrong. That was the right answer. First off. Okay. That was right. Definitely don't have it. Need to keep connecting junction boxes together until they're all in one large circuit. How far those junction boxes are from the wall so they can pick the right extension cable. X coordinates. Continue connecting until the closest unconnected pair of junction boxes together until they're all in the same circuit. What do you get if you multiply the x coordinates of the last two junction boxes you need to connect? Okay, so the last two junction boxes you need to connect. Okay, so we do, some of this is the same. Um, yeah, so we are still sorting in that direction. However, we no longer have an end to connect. Um, I mean, I can at least do as many as end to connect. I can at least do that many. Um, then okay, so all index pairs. Okay, at least start off connecting that many. Start off doing that many. Groups. And now our problem is going to be when the max of group num is larger than 1. So while max of group nums, and I know, there's like, yeah, larger than 0. We have, we have something that's not a 0. I'm going to say, I'm going to add a new okay, n to connect minus 1. Okay, so pair IDX is the last pair I connected. So the last pair I connected was that. All I did is that. Then what I do is I do pair IDX. It's 1. And then I say pair to connect equals all IDX pairs of pair IDX. And then I connect one of them. So connected bracket pair to connect 0 connected dot set default pair to connect 0 of pair to connect 1 and do the same in both directions. Okay, then I will do, okay, pair to connect, and then I do changed is everything. Then I just do this again, except I that. Okay, and this should then there, and then what do I want? Multiply together the x coordinates. So then I do pair to connect bracket 0 times pair to connect bracket 1 bracket 0. Um, oh, except that I want actually pair to connect is not a two, it's not a tuple. I want data bracket 0 data bracket. Okay, and then where idx int. Let me just check this. Pair to connect tuple int and data is list of hints. List I know it's silly to worry about typing when I'm just trying to get speed down, but okay. And let's see what my timing was. Okay, so what I started it at 10 after, so okay. Um, yeah, 27 minutes. It's not great, but what you gonna do? Okay, so that's Python. Down, do let's do some other things. Let's do this in let's do this in Go first, because yesterday I did the Haskell first and I just got bogged down. Oh. Okay, so first off, okay, and now this is data here, points, which will be an array of 3 unit 64 values. Scanner.scan, and for range strings dot split. It's not. This would be scanner.text, and this would be comma there. And then I say n comma underscore star conv dot parse uint u base 10 64 bits, and then points bracket index equals n. Oh, right. N vowels equals make free. Okay, let me just do this then. Var n vowels, and then I say n vowels that. Then I say points dot append n vowels there. And then this takes up points. This is points, and then these are uint 64, uint 64, 3, func dist squared between A, B, both of type 3 uint 64s to a uint 64. Yeah, switching languages, man. Okay, this is return a bracket 0. Yeah, no, I'm just going to do this one. Minus b bracket 0 times a bracket 0 minus b bracket 0 plus a bracket 1 minus b bracket 1 times a bracket 1 b bracket 1 plus a bracket 2 minus b bracket 2 times a bracket 2 minus b bracket 2. Okay, now part 1. Let's leave that down at the bottom for now. Okay, so first I need to sort all of the connected distances. So then I need to get all the pairs. So let's do all index pairs equals make int and then for x range length of for okay, for x in that range, y in that range, var pair to int. Actually, oh, append x comma y. Okay, can I do this? New I don't know how to do this in Golang. Golang array literal to int that. Okay. There. If x less than y. And yeah, I could adjust this. I could use a three arg for loop, whatever. It's not going to matter. It's going to be blindingly fast anyway. Find. Yes. X plus 1, y less than when raw lines y plus plus. There. Are the voices in my head happy now? Good. Okay, um, now I got to do this slices dot sort func all idx pairs func and a and b. Actually, a comma b and okay. So what I gotta do is dis1 equals dist square from raw lines of a one. Okay, and then okay, it's a minus b if I want to sort up. So a if a should sort earlier, if a should sort earlier, it should return negative. Dist a greater than dist b minus 1, else if dist b greater than dist a, return 1. Let's return 0. Okay, so now I've got all of that. So now I can take the first 1,000. Okay, so let me now do this thing. Func this will be yeah. So find group nums. And we're going to have a group num start, which will be a map from int to int. And we're going to have a max idx, which is an int, and we're going to have a connected, which will be a slice to ints. And this is going to return a new group num. Okay. Now, and it's probably going to return. Actually, we're just going to do that. So, we're going to start out with changed as the var int changed. Actually, I'm just going to do changed as a int max id x plus 1. And then for, okay, so max idx is actually going to be max idx plus 1. X change dot append x. Now, well, so this is go. So for when changed greater than 0, n changed was for x okay, for x in changed, or x in range changed, then for don't care, comma, pair in range connected. If, can I assume connected is both ways? Sure, I'll make connected go both ways. If connected bracket 0 equals x, why is that a problem? Pair bracket 0 equals x, then what we want to do is we want to say if pair bracket 1, oh, group nums is going to have to be, you know what? Yeah, everybody's going to start in a group that's one more than they are. And that's okay. If group nums bracket pair 1 is not equal to group nums pair, okay, group nums x, then g. You know what? Why? Why? if group nums bracket y min group changed dot append y group nums bracket y x x x. Okay. And then this is not, this is n changed, n changed, n changed, n changed. Okay, n changed. Okay, there. That should hold me. Find group nums. Okay, now slices sort func. Connected equals make to int make slice of pairs 0 for AIDX 0. Oh, I'm not passing an extra thing here. That's okay. 1000 connected append oh, there's probably actually a way to do this in one thing, isn't there? Can I just do okay. Yeah. Okay, now can I just call connect? No, I need to make group nums. Okay, so group nums make map int for x range len. Oh, we called this raw line still. We'll have to change that. Raw lines. You know, I'm going to change that right now. Data points. For x and range data points, do group nums bracket x plus 1, so that nobody is at group 0. Then now I want to find group nums. Group nums equals find group nums len data points connected. Okay, now the largest sizes. Okay, now size map. map int, let's just say uint 64, just because. And now for nums, not known genome in group nums, size map genome plus plus. Okay, now we need to find the largest three values. Var var 4 G size range size map okay, if G size greater than equal to B1, then we have B3, so B2, B2, B1, B1, G size, continue. If G size equal V2, you know, the same, the same. Paste. Okay. Da, 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 da. Turn V1 times V2 minus V3. Golang, go run day 8. Okay, what do we have here? 2. 25. Group nums. Oh, why do we have that? Why group nums X? $255. Well, that's not right. V1. Five one one. Okay. 255. Everything else is a group of 1. Okay, so that code is probably working correctly, and it's probably my group nums that is incorrect. Okay, so make int. Oh, x. $57. Cute. Okay. Well, that did in fact change stuff. Okay, so if pair one is uh, okay. Combine group nums. Um, okay. Okay, so group nums is not uh, coming out right. Group nums is coming out as 257, 1, and 1. So there's clearly something going. Let me let me check my method. Let me check that. Okay, so like yeah, so let's try 295 and 904. So let's say 904. Okay, that's not right. So okay, so okay, so what I'm looking here is I'm looking for two things that are obviously connected and that are in the connected set and that don't end up with the same group num. And it looks like it is claiming that everything always becomes connected to the same group as group number one. Okay, well that obviously I'm printing out group nums wrong there. No, no, I'm not. Okay, so three. Okay, so 0 is not ending up connected to anybody. But that's not necessarily a bad thing because 0 doesn't get connected to anybody in the first 1,000 connections. Okay, 291 and 813. Here, let's try those. 291 and 813. Are they both into the gigantic thing of twos? Yep, 813 is. And what about 291? 291 is also in there. Well, shoot. Okay, let's try. Uh, 8. We have, nope, that's, okay. I'm going to copy this. New window, paste all that, view, uh, um, there we go, word wrap. Okay. I'm going to go through connected. Okay. 839 to 854 to 56. Hmm. So it is concluding that everything gets tied up into 2. And it is concluding this because the connected map looks like this. Okay, I'm going to have to go back and ask here. Print. Yeah, one of the advantages of doing it in the language I know best first is because that lets me then check when stuff goes wrong. Okay, so what do we have here? 672, 875. Okay, so first off, we have those as the first several here. These are the first several connecteds. Okay. And now when we run golang, the first several connecteds are, yeah, they aren't anything like that. Okay, so what I'm wondering is maybe I connected stuff in the wrong order. Maybe I put this incorrectly. And I bet I did. Okay, 122636, is that the right answer? Was it just that uh, was it just that yep. I had those connected in the wrong order. Okay, I'm gonna have to finish the rest of this later, unfortunately. So, Golang partisans, Go not always an instant easy win, especially if you forget the convention on sort func and accidentally reverse it. Yeah, crud. Okay, so I have part 1 in Go only, and Pascal is, and Python is done, and I'll do Haskell later. Okay, back at this. Let's finish this off now that we've gotten this. Okay, we've gotten this first. We've gotten part 1 in Go to work. Just double check. Yep. Gotten part one and go to work. Let's finish off part two. Okay, so here we go. So remember the big problem we had in part one is that I'd swapped that so that we were using the furthest connected things and not the closest ones. Yeah, that was a mistake. So okay, so for part two, we have exactly as before. We do connected. We do that. And now um, we do we look for the lowest thing that is not part of the group that has 0 in it. Right. Okay. I know Go generally uses camel case, but I'll fix that later. Lowest, actually, let's just call this lowest disconnected. Or node. Or, okay, so for node, we already have range group nums if actually it's just some disconnected. If group num greater than 1, then return data points bracket, data points bracket pair idx 0. No, not data point. Return data points bracket all idx pairs 0 bracket 0. times copy paste 1. Okay. Um, or sum disconnected equals 0. Um, do connected dot append bracket plus plus. Okay. We want to try this. Okay. Um, oh, wait. That is quite correct. Okay, now, the golang is running correctly, although it's really slow. Um, and especially it's getting smoked by the Python code, which is not overly surprising since I do use a very different structure here for connected. So I don't want to spend too much time on this because I already spent so much time on the Golang. But let me just see if I can speed this up by switching my structure for connected here. Um, connected prime map from uh, uh, let's make this a map from int to slice of int. Um, or pair nothing comma pair range connected. Yeah. X, and then what do? I do if connected prime of X nil X equals int Y, else X equals, and then we do the same thing for Y. Y, 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 X, X, Y, X. Okay. Then I say changed if connected prime of if connected prime of X nil for Y range neighbors. Cut that, paste it there, delete that. Okay. Okay. So all this does is it first goes over our pairs and it turns them into the right structure, and then it does that. Let's see if that makes a difference in runtime. Well, that definitely sped it up. I could probably speed it up more by only doing that once, especially since I am adding to it. I'm going to skip that though, because I think it's acceptable right now. And we're going to we're going to try it in Haskell now. Yeah. Yeah, 3.42 seconds. That's really not great. I really should speed this up more even, but that's fine. We spent long enough on Go. See, so don't save. Okay, so Haskell. First of all, make sure you read AOC 8. And then, okay, so data lines is that, and data points, let data points is going to be map Okay, int. Oh, seriously? Okay. Not sure why there are two formatters both called exactly the same thing, but whatever. Okay, and now part one, data points. Part two, data points. Okay. Where? X1, Y1, Z1, X2, Y2, Z2, X1 minus X2 squared plus Y1 minus Y2 squared plus Z1 minus Z2 squared. Okay, now what is this going to tell me? Nope. Okay. Yeah. Okay, so that's the square of the distance, and then I need to find for every pair of points. Where? All pairs equals x comma y, where x is in 0, minus 1, y, x plus 1, data points, minus 1. Here, I'll make that minus 2 there. All pairs. Sort on. All pairs not, and then all pairs sort on. Data points by I want to sort here, and I want the negative distance because I want to have the biggest distance. No, I want the smallest distance first. Right, so I want to sort on this square data points x, data points y. Okay, all pairs, int, connected. M dot from list width do. Wait, no, no. Connected pairs equals take 1,000 all pairs. Now, graph equals m dot from list width s dot union do do, 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 do. So x comma y pulled from connected pairs, and then x comma y pulled from connected pairs, and then I want x comma s dot singleton y comma singleton x. Okay, and then what do I want? I want grid nums. Find grid nums m dot map from int to int. That's old grid nums. And then I want m dot map int s dot set of int m dot int. Old grid connected. Okay. So what am I doing? I'm finding all of the grids, and then when there's single change, I go for the next thing. When there's a single change, I go for the next thing. Okay. So I want to do go bracket go. Fine. Go bracket equals old grid. Go pair pairs equals let x equal y equal pair in if no x num if let x and Venus equals um neighbors equals map find with default um map okay A and then K x grid num x grid num um map s dot map um connected m dot find with default s dot empty um s dot empty x connected in undefined. Okay, I just want to check that this type is what I expect. And is a set int in if s dot null neighbors grid num or s dot find min then go pairs else find grid nums m dot insert key value. Okay, I think that there's something better on than this that I can go to. Something better than that that I can use as part of a match. Google find min. Google find min set. Okay, yeah. But what I want to do is I want to do lookup min. Yeah. Case s dot lookup min of nothing go pairs just x where just n where n greater than equal to x grid num go pairs just n find grid nums m dot insert x n old grid connected. Okay, there we go. There's that loop that, while we're not done, keep looking. That should, we'll see if that works. It should work. Probably work. Grid nums equals grid num 0. Initial grid nums equals m dot from bracket 1 okay, grid nums equals find grid nums 0 connected graph. Grid nums is map int. Now we need to find the size and find the largest 3. Find the size, so then yeah, size map m dot from list width plus this is going to be y comma x for x comma y comma 1 for list grid nodes. Now size. Now what do? We do then we need to find the largest three. So size map. Um, there. Okay, now fine. Now, okay. And now what was it? It was multiply together the sizes of the largest three. One, two, two, 6, 3, 6. I believe that's the correct answer. Yep. Okay. Now, part 2. What do I got? Well, I do basically that. Oh, I do basically that, and then what? So that's grid num 0. And then what do I have? I have what do I want to do? Any. Okay. is all. Keep going. Okay, so we keep going if the grid num candidate. Okay, then we keep going if that's true. Okay. And then, okay, we keep going if that's true. But if it, okay, keep going, that's true. So what am I going to do? Um, okay, yeah. So that we're going to, okay, we got to find the one where we're disconnected. And um, okay, unfortunately, I have other things coming up, so I need to pause this again. I'm sorry. I really hoped that I'd be able to do all of these problems straight in one recording session, but obviously I've already screwed that up. So I will come back to this later in the day when I can. And we're back. Okay, so um, while, while I can keep going, I'm just going to keep applying this. And now, in theory, I could keep taking this, but at the very least, I actually know a lower bound because I know that I'm going to have to do all the pairs until the last, until at the very least, the last of the nodes is in the set. So, um, so I can take more than 1,000 to start with, and that'll speed things up. And I just realized that I recorded all of that without wearing my headset, so I don't know if my microphone actually caught any of that. Anyway, what I said is I'm going to uh, not just take the connected pairs, take the 1,000 initially. Instead, I'm going to take enough pairs so that I have everything, so that I have every node connected to something else. Now that won't be enough, but that'll be a start and that will be much further along, and probably that will help. So I'm going to do this. Find CP of our nodes. Pairs. And yeah, write down. Let me write the type of it. Find connected pairs. That's going to take the um, set of that's the so far made so far as set and remaining pairs. That's another set of eight. All nodes equals ascending list. Why not? Let's minus one. Okay, so find minimal CP if um, moves so far, and actually, yeah, so what is this going to then return? So what it's going to return is it's going to return two sets of tuples. And one will be the doesn't want to, because it doesn't want to, oh, right, it doesn't want to do let's do S. Okay, so if we have all the those, then we do uh, pairs. If we have now, this should never happen. But just because could are nodes so far x best equals comma y equal rest equals x comma y CP so far s dot add s dot insert x s dot insert y node so far rest. Okay. Okay, and I'm sorry that we are going beyond that. I do have the text size up a little bit. Okay, so find minimal CP so far. Okay, so then minimal. So then, yeah, we start connected pairs. Minimal connected pairs equals They're not connected. Remaining. You know what? I'm going to start using some abbreviations because these are too long. NCP. On minimum connected pairs. That. That's empty all pairs. Okay. Now, yeah. Okay. So use connected here. Connected grid. Okay. So we're gonna do we need the last pivot that was connected. Okay. Last needed pair. Okay, last needed pair is going to get stuff we've connected so far. Stuff we've connected so far. The the this and then okay, the last thing here is stuff we've connected so far, the connected grid, and the remaining stuff. And it's going to return the last pair that we needed. And then we'll have to, so that last needed pair of, um, actually, we don't even need sequence. Yeah, we're gonna say of connected grid and x comma y rest, and actually last needed pair underscore and bracket is going to be um, okay, but fine equal um that's stuff union union with no union m Okay, M no, union with, which takes a combining. Combining function is s dot union, and map one is m dot and map two is connected to. Um, okay, and now oh, find in if keep going grid nums, then last needed pair connected gr prime rest else x comma y. Um, it's 0. And what I need is I need what last needed pair was grid 0 meaning um, underscore underscore uh yeah, data points 2 2 yeah. I guess I didn't need lambda case. Okay. Well, oh, oops. There. I have a feeling that's, I don't remember exactly, but that's wrong, isn't it? Yeah. Ah, yeah. Well, let's let's see if we can do it without. Let's do take 1,000 there's drop 1,000. Yeah. Let's just see that. That shouldn't because that was just an optimization. And if the optimization is wrong, then because that was an optimization that we hadn't tried anywhere else. So wow. Well, it's really taking its sweet time here, isn't it? Okay. So come on guys, what do I need to do here to do this significantly faster? Okay, well, this is not working out well. Okay, so, okay, so if I do that, is it okay if I goose myself with the existing find grid? I think so. Okay, so I'm gonna do this. Grid num's old. Last needed pair become gets called with. Okay, and then this becomes just that. Paste that there. Okay, now that looks a little more like what I expected. 927. Okay, yes. So, clearly this didn't work. So I'm just going to and I'm going to say here yeah. Okay, so clearly this it finds more than we need. Um, And so what I'm going to do is here, I'm going to do trace length rest. Okay, so when we have that, okay, that's how much stuff is left. And now if we change this to say all pairs, drop all pairs. We have that to say that, then four nine one 617 616. Okay, um so it goes one too far. Huh. So notes so far 491 616. Okay, so actually what I care about here is I care about s dot size um, nodes so far. Length of data points. Okay, so we care about that. And we don't care about all nodes. Just wipe that out. Um, right, because we're taking the next thing. So we need the one before that. Right. Okay. Yes, because we're taking all. Let minimal let new note so far. That in if s dot size then then remain else. Okay. There we go. What about that? Okay. And here we can drop that trace call. But this also tells me of a way to speed up the golang thing by a lot, and also honestly the Python thing as well. Um, but first let's deal with golang because that speed was awful. So I'm gonna have to drop a new marker here of optimizations. So here we have part two. Um, okay. So we add a pair index. Right. So what we have to do is we have to find the right pair index. Actually, 0 and make map int bool. You say a set and go. Let me see before line of nodes less than line of um, nodes bracket data points. No, no. I can experience that is 0. And then oh, that's a haskell. Sure. Okay, so that little optimization there is useful. Let's see if yeah, so 0.3 seconds. Um, yes, that little optimization is useful. Okay, so we are, I think we are all done. Yeah, yeah. Oh man, everything here. UC8.py. What do I have here? What do I have? Oh, I just have a commented out. That's fine. Commit, git commit -m day 8 haskell and golang. Okay, well, this has been a slog. Thank you for staying with me. If you did, thank you for skipping around if you didn't. And if you aren't seeing this at all, well, you know what? Have a good rest of Advent of Code.